Okay, so today we're going to be talking about Module 2.2, and this is going to be Part A, which we will be starting to create and solve equations. So 2.1 was looking at expressions and how we modeled and created those, but now 2.2 is going to be focusing on equations. Now, before we get into the building of equations, which is very similar to the expressions as we'll find, the idea is that we have to understand how to solve some more complex equations, not just our basic one-step or two-step. We're going to be looking at what we call multi-step equations. So if you look, what our statement is for today is we're going to use simplification methods and the distributive property in order to help us solve equations. So we're going to kind of take some of this knowledge that we've created and that we've built through our pre-algebra classes and some of our one- and two-step procedures to help us solve more complex equations. So the idea is that we're going to be looking at some vocab. Now, vocab that we're going to be talking about today specifically is something that we consider like terms. Now, like terms are basically two or more terms that have the same variable. Now, a couple of examples of this, something that you may or may not be familiar with already, is the idea that we have 3a, and if we say that another term is 3b, these are not like terms because they don't have the same variable. Yes, they share the same number, but they don't have the same variable, so that they cannot be like terms. An example of like terms would be, let's say for example, 5x and 4x. Those are like terms because they share the same exact variable. So coefficients, so the numbers multiplied in front, coefficients don't matter. It's the variable that decides what a like term is. Now, the second thing that we're going to be talking about is what we consider the distributive property. Now, the distributive property looks like this. You have a variable, we'll call it A, outside of a set of parentheses, B plus C. And so the idea is that our order of operations tells us to do what's in parentheses first. Now, because of the way that this is set up, with these two things being not like terms, because B and C are not like terms, I can't get past my order of operations in order to proceed with simplifying this or solving equations that we'll have in the future. And so the way that we do this is we take these values, or the value that's sitting out in front, because this is being multiplied by this set of parentheses, and we distribute this to both terms of this parenthesis. And so what we come up with then is that we have A multiplied by B, which is simply just AB, and then we have A multiplied by C, which is AC. So the idea is that that value in front, no matter what it is, gets multiplied by both pieces on the inside of the parentheses. And if you look, now all of a sudden we have gotten rid of those parentheses, and we have these two pieces that we can find values to and then get an answer to. Now, the commutative property, which this is something that you were also taught kind of before this class, but the idea is the commutative property tells you that you can add in any order. So this is going to be helpful to us because we can start shuffling things around and moving things. But basically what we now know is, if you really think about this, these two things are terms. So you can swap entire terms. So it's not just about adding in any order, it's about changing the order of the terms, so long as you keep everything in its true value. So positives stay positives and negative values stay negative, and we'll take a look at those as we go along. But these are the three things, the two properties, and kind of the vocab that we're going to be using when we talk about today's lesson. And so what we're going to do is we're going to talk about combining like terms. So the idea is that we might not know what the value of a variable is, but we can simplify things by getting rid of multiple instances of the same variable. So it's almost kind of like taking two buckets of something and pouring it into one larger bucket, because they both will contain the same objects or the same things. Now, like terms, remember, have the same variable. So we're looking for terms, or we're looking for pieces that have exactly the same variable. If they don't have the same variable, you cannot add them together, and that's what we looked at with our first couple steps of our one-step or our two-step equations. So when I look at this first part here, we have 8n and we have 5n. The only thing that matters is the variable, and so these are indeed like terms. And so all I have to do is combine these together, and the way that I do that is I only combine the numbers. So I leave the variable the same. So to combining like terms, your first step is to add the coefficients. So we're going to add coefficients. And then the second thing that you want to make sure is that you keep the variable. So the variable does not change when we're doing these things. So the only thing that you're combining, the only thing that you're adding or subtracting is going to be the variable. So when we look at this, 8n plus 5n is going to combine to give us basically 8 plus 5, which ends up being 13. And so the combined value, so 8n plus 5n, is going to give me an answer of 13n. So the idea is that we're only combining variables, or only combining coefficients, and keeping the variable at the very end. Now, when we look at combining numbers and variables, the idea is that like terms don't necessarily have to be the same variable, even though that's like the main point here, but also just numbers are also considered like terms, because those are things that we already know how to add and subtract together. So the way that we do this is we want to first identify what our like terms are, and I'm going to use that, or I'm going to do that by using boxes and underlines and things like that. So we want to make sure that one, that we can include our not our coefficients, but we include the operations. So first of all, I'm going to look for the variables. So I'm going to say positive 9x and positive 9x over here. Even though those are identical, those are considered like terms. So I'm going to add these two things together. Again, back over here, I'm going to only add the coefficients. 9 plus 9 is 18, so I have 18x because I'm going to keep the variable. Add the coefficients, keep the variable. The next thing that I'm going to look for is everything else. So we have just a regular number here and a regular number here. Now, because of my commutative property, this means I can add and subtract in any order, and so I'm going to say that this is going to end up being 1 minus 8. Now think about what this means. Now we have to kind of understand what 1 minus 8 is. If you want to change this to addition, remember this is 1 plus negative 8 by adding its opposite. So you learned adding the opposite earlier. And so that ends up giving us negative 7. And so the rest of our problem here is 18x minus 7. So we're combining variable terms and we're combining constant terms to give us our final expression. So just be on the lookout for combining like terms, finding the variables, finding the regular numbers, and combining those in any way that you would want to, so long as you're adding only coefficients, keeping the variables, and then being careful with our positive and negative values. Alright, so now we move on to the distributive property. Now the distributive property is just kind of this fancy way that we can use multiplication to get around our order of operations. Because like I said, if we kind of take that idea of having like terms, if you notice what we have right here inside this parentheses is n minus 2. Now technically I cannot add those two things together because 1, these are not like terms, and 2, I don't even know what the value of n is. So I need to know that first before I can do that, then go through my order of operations. So instead, we do this thing called simplification, which is a way to kind of get around that so that we can put things in basic terms so that when we simplify them, then we can use those for other things and then just plug in the number rather than doing a bunch of these operations. And so we're going to just use our simple distribution property. Now our simple distribution property is taking the number that's out in front, no matter what that is, positive, negative, even if it's a variable, it still makes the same thing. And so the idea is that we're going to multiply 7 by the number here, the first term, which is n, and then multiply 7 by this other number, which is 2, and then keep the operation that is in the middle. Now that's going to be the important part, is keeping that operation. Now, if you want to, you can also think of this minus 2 as being a negative 2, which will help you with simplification and combining like terms. So we're going to go ahead and distribute that. So 7 times n is just 7n, and then 7 times negative 2 or minus 2 would be minus 14. So 7 times 2 is 14. Keep the operation. And so that is just your simple distribution property. You take that number that's out in front and you multiply it by every piece that's inside the parentheses, no matter how many pieces that there are. Now, if you look at the second example, it's something that we would consider distributing and combining our like terms. So it basically takes the previous page and combines it with this page to kind of put both of these things together. Now, here's the trick and what I was referring to as our distributive property. Now, the distributive property doesn't always have to be the first thing that's in front of you. And so we're going to take this 2 here and distribute it. However, we need to be very careful because if you notice, this is a negative 2. And even though it says it's subtracting 2, we're going to treat this as it's a negative 2. So instead of distributing just a positive 2, I'm going to take operation and everything and distribute that. So I'm going to multiply the m by negative 2, and I'm going to multiply the 7 by negative 2, and that will help me out. So when I distribute this, it would be a minus 2m, so that subtraction stays there, and a negative 2 times a positive 7 gives us a negative 14. Now this 6m that's out here in the front, that didn't have anything happen to it. I'm not distributing that because that's a whole different part. The idea is that I'm just going to bring this down, and it's going to be 6m minus 2m minus 14. Now I go all the way back to the combining step and say, well, 6m and this negative 2m, those are like terms, so I can add those together, add the coefficients, leave the variables. 6 minus 2 is 4m. We bring down the 14 because that's still part of the problem, and now we have our simplified answer. Now if you look at every single thing that we simplified so far, the idea is that there's two terms. There's a variable and there's a number. There's a variable, there's a number. And this is going to be key as we move forward because we're going to turn these into how can we do this with an equation. So if we look at what we refer to multi-step equations, and so what we're going to do is we have a couple of steps that are listed here on the side. The first step that we're always going to try to do is get rid of fractions, and that's something that we'll go over a little bit more in detail. Next, we're going to look for distribution. So if you look at this problem, there's no parentheses, so we don't have to distribute. So in this particular case, we don't have to worry about that. But the next step is that we're going to combine like terms. If you notice, there are two instances of the variable b. We want to combine that to its only one, because the idea is that when you're having an equation, we want to solve for b. And it doesn't help us if there's more than one b. So we want to combine that down into only one instance of b. So we're going to take and underline our like terms. Now notice what we're going to do with this is that we're going to keep this separated. So we only care about this one side. We're not working with that other side just yet. We're only combining everything that's on this side of the equation because that's what we can work with. So we're going to combine coefficients, leave the variables. So 2b plus 7b gives us 9b. That minus 2 stays the same, so we're going to keep it as minus 2. So if you notice now, we have one variable and one number equaling to something else, and in this case is 16. Now if you really look at this, if you look at the next step, it says move variables, but we don't have to worry about that. That's something that will come up. And then adding and subtracting, the idea is that this is now a two-step equation. And we know how to solve two-step equations. We're going to add and subtract first. So we're going to add 2 to both sides. So we have 9b is equal to 18. And then now we're going to divide by 9, and so b equals 2. So the idea here is that we can solve multi-step equations by doing all of these things that we already know how to do, but combining them together. Because the point of combining and the point of distributing is that we can make this a two-step equation. So we want to simplify to two-step equations because those are what we know how to solve. And so finally, we're going to put all of this stuff together. So we're going to clear fractions, but we don't have any fractions, so we're good with that step. So we're going to see now that we have to distribute. So when I look at that, I look for the parentheses. So here's my parentheses. I go to the number that's in front of it, which is negative 3. And I'm going to distribute that to both pieces inside of this particular set of parentheses. Now I'm going to take special care because we have a negative here and a negative here. So first of all, negative 3 times 3, which is negative 9. Negative 3 times negative 3r, let's multiply the numbers. Negative 3 times negative 3 is a positive 9. and then since there's the variable r, that has to go along with it, so we have 9r. Now this minus 3 at the end, that still stays around because that's not anything that we worked with. That doesn't get distributed to, it's just kind of there hanging out. And then I'm going to go ahead and I'm going to draw my line through the equation so that we can separate the two sides here. So that's equal to negative 39. So that always stays the same. So I'm really only working with the left side over here, working with this stuff. This is just negative 39. There's nothing that I have to distribute. There's nothing that I have to combine. It's just over there waiting for me to find it equal to something, because that's what equations do. We're only working with one side at a time. So now we have to combine like terms, so we have to identify what's similar. So there's a 9r here, but if you really look at that, there's no other r's that are part of this problem, but we have a negative 9 here, so I'll double underline that, and a negative 3 over here. Now being very careful, negative 9 plus negative 3 is actually negative 12, and so if I combine these things, I have 9r, and I'll say minus 12, because negative 9 and minus 3 gives us negative 12, is going to be equal to negative 39. So if you notice, I just combined that one side and then still set it equal to the negative 39, and then now again, this is a two-step equation, plus 12 to both sides. So negative 39 plus 12, so I have 9r on this side, equaling, being very careful with your positives and your negatives, would give us negative 27. That's not a 7, so we'll fix that. So it'd be negative 27. And then our next step here is to divide by 9, and then divide by 9 over here, and we have r equals negative 3. So the idea with this distribution and combining like terms is to make things as simple as possible so that we can get to, again, a two-step equation that we know how to solve. So just to kind of catch this up, we want to be able to simplify in order to get to a one-step or a two-step equation if possible. Obviously the best case scenario is a one-step equation, but two-step equations aren't so bad, so if we can get it to there, that's fine. And then our commutative property and our distributive properties. So making sure that whenever you see a number outside of a set of parentheses, that you're going to be distributing it from one term to the next, so that you can use multiplication to be able to get rid of parentheses so that we can actually solve things. And then knowing that our commutative property will allow us to write things in different orders with just addition. Okay, so that's going to wrap it up for this video. We'll see you next time.